All right. I think now we're going to switch so I can have a little break, and Orv is going to take over and do his next installment of Taming the Terminal. I sure hope that the efforts that he's been putting out these past few months has been helpful, and that some of you have tested it out and tried it. You know, given a try to do these things. The more you try it, the more you're going to like it. I'll tell you that much.
So, we all ready, John? Does that look okay?
That looks great.
Good. This is the third chapter of Taming the Terminal, and as I was working on it, I got to thinking that there's no point in showing Linux commands if you don't have to, if you can't interpret the results you get. So today we're going to do a little bit deeper dive on what you see as we go through these. Primarily, but not completely, we're going to talk about drive and file system information and the commands that will reveal that information. This may have come up before. It's the file system hierarchy that most of the Linux distributions follow. There are some minor variations. You have your C drive in Windows. It's called root in Linux, which is unfortunately the same name as the administrative owner of all of this stuff, root. Same in Unix too, by the way. And the top level in Windows is C, and the root level is /. Windows got it wrong because they copied it from DOS, which got it wrong. Because they copied it from CPM, who got it wrong. They used the \. Anyway, when you install a program, you're not just installing the binary. You're getting a package. The binary will either be in bin or sbin, and sbin are system binaries, as opposed to like utilities or a word processor or something like that. The configuration files will be in /etc. If it's a small program, it'll sit in /etc. But if it's a large, complicated program that has lots of varied configuration files, it'll make its own directory, typically the name of the application, under etc, and all of its configuration files will be there. Home directors are in /home. They're created there. I have /home/obeach, for example. What else? There's a bunch of other stuff in there, but in general, when you follow a file path down to a folder and then ultimately to a file, this is how you'll be navigating it. Going to talk about drives, non-volatile storage. Historically, it was a rotating drive, so we'll talk about those. Windows drive names were derived from DOS, and before that, CPM. You had your A and B were typically floppy drives, and when DOS got into the big time and had hard drives, it went on to C, and maybe when CD-ROMs came along, it was D. Linux drive names are different. They don't use drive letters exactly. Your floppy drives are FD, floppy drive. First one is A, second one is B, if you have to. When hard drives came along, originally they were gigantic. I'm revealing my name, but the first disk drive purchase I did as an IT manager many years ago was for a 600 megabyte drive that was about 2 feet across, 1 foot tall, and 3 feet deep. And we were stoked that we got 50% more storage for the same $12,000 we spent for the earlier drive. But anyway, those particular ones were not MFM, but the very early drives you could get for a PCAT, and those vintage were MFM, modified FM. Back then, the electronics, the chips and stuff were a lot larger. You couldn't cram as much in any given area. So the drive controller electronics were on a separate card for an IBM PC. And it was a full-length card. Then it had some cables going to the drive. Over time, as the electronics shrunk and they got to the point where they could fit on top of the inside the drive, they did so and moved all that controller stuff into the drive, leaving a much simpler interface. And those were integrated drive electronics drives, IDEs. And they were called HDA, HDB, HDC, obviously HD meaning hard drive. And the partitions, separate chunks of the hard drive that were mounted in different places or used for different folders, were HDA1, HDA2. If you had a second hard drive, its partitions would be HDB1 and HDB2. Then SCSI came along, small computer system interface. For multi-platter drives, you had to have a more complicated command set, and they were called SDA, SDB, and SDC. Then SATA replaced PATA, P-A-T-A, parallel, which was preceded by ATA. And the AT stands for PCAT. So anyway, SATA uses a different command set than SCSI, uses the same thing as PATA, but in any case, the drive letter is the same, SDA, SDB, SDC. And the partitions, as you would expect, would be SDA1, SDA2, SDA3. And pretty much any Linux distribution, when it installs, will create separate partitions, typically 3, at least in the distributions I've seen. By the way, you can override that and create your own partitions if you're feeling bold. Usually I don't bother. So a little bit more. Modern computers, anything newer than 3 or 4 years, are starting to use non-volatile SSDs. The SSDs originally, when they came out, the solid-state drives had a SATA interface. But as they became faster and faster, they outran the SATA interface. It's good for about 600 megabits per second. And as those drives get faster and faster, they're limited by the bandwidth of the SATA interface. So they've graduated to the NVMe drives, which actually sit on one of the PCIe buses, the buses on the motherboard that are much, much faster. So anyway, those would be NVMe 0 and NVMe 1, and every desktop computer you buy will only have one of them, and it'll be NVMe 0. However, because NVMe drives can be used on very large corporate installations, they have namespaces used for different applications or purposes. Isolating, it could be one company from another, I don't know. You now know as much about namespaces as I do. But anyway, they have partitions also. The first would be NVMe 0N1P1. And by the way, your drive will have NVMe 0N1P1 and P2 also, because that's the way they format them. And anyway, here's a picture of them if you haven't seen one. Tiny little slot typically on the motherboard and one screw or clip to hold it down. And this is a Western Digital. Doesn't say how big it is, but I suspect it's gigabytes or terabytes. So anyway, the first command I wanted to talk about at length is df, disk free. What kind of space do you have? It lists all of the partitions, size, what's used, what's available, percentage used, and the mount point, which we'll talk about in a bit. And you can ignore anything that says tempfs. It's volatile, it comes and goes, and you can't do much with it. The operating system creates them, manages them, and you don't have to worry about it. Now, I didn't mention it when we were looking at the file structure, the file system, but in /dev are all the devices. And a device is a file. Everything is a file in Linux. You've probably heard that before. In any case, you can see up at the top, obeach at SC. SC is my wife's workstation. It's sitting about 5 feet away. Ever since my daughter and I introduced her to computers, she's referred to her computer as stupid computer. So SC stands for stupid computer, and that's been that way for 15 years. So anyway, you can see /dev/SDA3 and /dev/SDA2. So those are partitions on the first SATA drive, partition 2 and partition 3. There's an SDA1. If you look at SDA2 off to the right, it's in the /boot directory and it's EFI. I took a look at SDA1 and it's /boot/BIOS. So it's installed but not used, not mounted and not used, because this computer's new enough to use EFI instead of grub, which is the earlier boot stuff for Linux. Used to stand for Grand Reunified Bootloader. So anyway, you got dev SDA2 and dev SDA3, and over on the right-hand side, you can see the mount point. /dev/SDA3 is the root partition. In other words, everything in the everything that you can access on the computer is in /root and subdirectories. We saw that at the top level of the file system. /dev/SDA2 is used by the system and not by the user. The other weird stuff here is this 192.168.1.10. That's the IP address of my network attached file server. It's just a box with a couple redundant disks in it, has an IP address there, and it runs an NFS server. That stands for Network File System. It's one way to attach stuff that's remote, not local. Linux uses Samba to connect to Windows SMB drives. And I forget what SMB stands for, but I use NFS to mount stuff here. And over on the NAS, you can see there's only one volume 1. I didn't see any need to make any more than that. And under that are three directories. Our stuff is all of our documents and stuff that we want to retain. Photo is all of the photos sorted by year, month, and day. And there's a lot in there. I'm getting close to 100,000 since I've been maintaining digital photos since about 06. Scratch is just what you think. It's Scratch. It's a Scratchpad area. I download distros and put them in there so they don't occupy anything else. And you can see that on my computer, they're mounted on top level directories that I made called R stuff, photos, and Scratch. And that way, when the system boots, it mounts that volume, that NFS volume, in those 3 subdirectories. So another look, by the way, you don't ever use df. df will show you all of the number of bytes. You'll get very large numbers undersized, used, and unavailable. So df -h is human readable. That's what the -h means. So for any file system, most file system commands that let you view stuff, the -h is what you'll want to use. Okay, here's a df command on my computer, which is called w6bi-house-pc, w6bi being my ham radio call sign. Same df -h command, ignoring the tempfs, and you can see that my drive under /dev is NVMe 0N1P3. And there's also an NVMe 0N1P2, and there's also a P1, same deal. And you can see that on mounted, I'm as root here, it shows everything that's mounted on my computer. The same NFS volume 1, Scratch, photo. I also have audio mounted there. I've ripped, I don't know, 150 of our CDs, and the MP3s are sitting there under audio, under music, under artist, under album, and then the songs. And that's pretty much it for that. Again, using df -h. Okay, the su command lets you become someone else. I'm logged in over to Stupid Computer. I said, who am I? I'm O Beach, because there's a login home directory for my wife, B Beach, and one for me, O Beach, and I think there's a couple for our grandkids too. So anyway, who am I? I'm O Beach. I did an SU, switch user, space dash / B Beach. And because I'm logged in as an ordinary user, I have to type her password. Since I'm system admin, I know what it is. And then I didn't do who am I there, it would have said B Beach. Then I did an SU space dash. Well, if you do an SU space dash, it assumes you want to be root. So it asked me the password. I typed it out and it doesn't echo it back. Then you can see I'm rooted SC and who am I says root. Okay, so now I'm the Linux god over on stupid computer. You'll notice I used a dash. I could have done SU B Beach and become B Beach. The SU dash ensures that I also acquire her environment, her search paths, her directories, and stuff like that. You always use SU space or dash B Beach. And by the way, to get out of it, you just type exit. I'd have to do 2 exits here to get back to O Beach at SC. So SU is how you become someone else. If you only have a single user on your computer, you could use it to become root, or you could use sudo. This is the Debian and Ubuntu derivatives typically use sudo. You can see at the top, I'm over there as me, an ordinary user trying to do an fdisk of dev SDA. And it told me to take a hike because I don't have permissions. But if I do a sudo fdisk / dev SDA, it says, okay, you're there. What do you want to do? Now, sudo, the way sudo behaves is configurable. There's a sudoers file, and you don't edit it with VI. Don't do that. If you want to change the way sudo behaves, there's a VI sudo, but you need to Google how to make those changes. There's 3 things you need to do. Add a user in there, although when you create the distribution, generally the first person you add will be put into sudoers and be able to do sudo. And there's 2 ways it behaves. You can type sudo fdisk / dev / SDA and have it prompt you for your password, so you're sure that the person typing it is actually that person. Or in a household like mine, where there's just the 2 of us, I've told it, okay, OBeach can sudo anything without being challenged for the password. So anyway, that's what sudo does. And I've noticed that if it challenges your password, there's some amount of time where afterwards you use sudo again. It won't ask you. It assumes you're the same person. It's very handy. I'm old school. I typically do SU space dash, do all the work I need to do in root, and then exit back to the normal user. Okay, we need to talk about the free command, and you'll notice it's free-m, and M means megabytes in this case. On my machine here, I have 16 gigs of RAM. It's a Dell desktop that's not even 2 years old. And there's 2 rows, mem and swap. So total memory is about 16 gigs. Used 6,245 megs. Now, it's not used at that moment. It's used since last boot. And the free next to it is the amount of RAM in the system that has not been touched yet since the last boot. It's virgin, untouched. Shared, I don't need to talk about. Buffers and cache are chunks of memory that have been used for buffers or cache, but the way Linux works, when you run a program or something and it needs some RAM and you exit out of it, it will leave it in RAM for quick access next time if there's RAM available. If that program's not being used and it needs to get used by something else, Linux will pull it out of a cache or buffer and use it. And currently free is what's really available. The problem with the free memory, if you talk to somebody who's really into Linux, a senior sysadmin or something like that, and you ask them to explain that, say, explain free memory, and they'll tell you what I told you, but typically they'll say, but in some cases, or usually, there are a lot of little exceptions to this here and there, but basically that'll tell you what your system's doing with the RAM. And typically it's not very interesting. What you really want to be concerned with is swap. This system has 2 gigs of RAM. A few distributions don't use swap now. That's a bad idea, and I'll explain why. If your system has memory pressure, in other words, you don't have 15 gigs, you only have 2 gigs or 4 gigs, and you're doing a lot with it, the numbers for free and available will start dropping down. And if it gets short, it will swap some unused chunks of memory out onto the hard disk, to the swap drive. That keeps it running. It has a performance penalty. It's not as bad now with SATA and NVMe drives as it used to be with the IDE drives, but it will really slow your computer down. So if you see the free swap at 0, you're in trouble. In fact, you'd be lucky to be able to display the free command. It will see, like, you'll see your disk drive swapping repeatedly in and out, and response very, very slow. Now, in spite of having lots of RAM, once in a while you will see the used swap go non-zero, a couple hundred megs or something like that. For some reason, Linux occasionally pages stuff out to swap, just quick and dirty to get it back. I don't know why. It's not a memory problem. So don't panic if you see anything other than 0 now. You panic when that 2047 under free starts getting small. In fact, if you're using large chunks of swap, it's probably time to reboot or think about adding more RAM to your system. Okay, I want to talk about this a little bit. You'd think -H is human in this, and it is, it's human, but you'll notice the amounts look funny. That's because in the metric system, a kilo is 1,000. But in computers, a kilo is 2 to the 8th, 1,024. So they differentiate between them. Some people use this, some don't. Some will, you can see the free -H is reporting amounts of memory in, let me get it up here, in gigabytes, which is 1024 times 1024 times 1024, or about 1.073 gigabytes. I had to put this up there so you weren't confused if you happen to use free -H. Just thought that was interesting. How do you find something on your system? I mean, back when there were floppy drives, that wasn't so hard. But as systems started to use hard drives, you get to be able to store quite a bit more on it. And the original method for locating things was called find. And you can see the command up there. I preceded it with the command time. If you precede any Linux command line command with time, it'll run normally and then report how long it took to run. Behind find, you see a dot there. That means find starting right here. A dot means right here in Linux. -type is a file. You could look for directories. And -name, I was looking for something that has new UI in the file name. Well, I didn't show the results because it shows you every file and directory it's searching through. Very tedious. And you can see that it took 8 seconds to look in my home directory, which is pretty large. 8 seconds of real time. Took 217 milliseconds to display the results, and 696 milliseconds of system time. Remember, it's multitasking. Of that 8.189 seconds, it only spent 0.696 of system time. Well, this worked okay. People used it a lot, but as file systems got larger and larger, mounted on larger and larger drives, it got to be where it could take minutes to return an answer. So early on, they came up with a different location solution. There's a program called Locate, which I'm pretty sure is on every Ubuntu distribution. And the package is called mlocate, and it actually consists of, well, 3 parts. there's a program called Update DB. What it does is periodically, I think every 24 hours, it rummages through your file system, locates stuff it hasn't seen before, and updates an existing database of locations of files. So when you run locate for the file name, it already knows where it is. It pulls it out of the database and displays it. And you can see that it took 5 milliseconds to display. Much better. One slight gotcha. If you've newly installed a program with all of its packages and you go to locate it, you can't because Update DB hasn't run. In order to get back that, as you sudo update DB and it will run, it just takes a few seconds, and presto, you can use the locate command. One other one I found is plocate. The package name is plocate and the program is plocate because you can't have two programs called locate. So anyway, plocate's claim to fame is it's faster. Did I take a picture? I did. No, let me go back. Plocate, when I ran it on the same one, ran about 3 milliseconds of real time, and the others were reduced accordingly. So it is a little bit faster, unless you're managing a drive with, I don't know, 100 terabytes. I think the distribution provided locate command will be fine, but this is really recommended. DU is disk utilization. If you just say DU, it will show you every program underneath where you're at, where it's located, and how big it is. And I had to hit more so you could see the command. And this is just the first page. And it'll show hidden files, by the way. The right way to use it is either DU-S, which is a summary, or DU-SH, which is the human readable summary. And you can see that my home directory on SC is 428 megs. So DU is very handy. That's all I'm going to cover today because that was a little bit of a brain buster. And we can go for questions here. And if not, my job is done.
Your job is done.
Yeah, very good.
Yeah.
I like seeing the commands with the results and going over what it does. And again, this is what I'm saying. Do little things. Just have the fun to do the things about LS that we've talked about before, to list your things and you know, DFs and SUs or the freeze. Just get started. Just, you know, get started little by little. And then later on, you know, in chapters 4 and 5 and whatever, you know, or will show us some things to run. And we've even talked that later on, there's things called scripts where you can write up something and then with a short command or even a keystroke, have it run a bunch of stuff for you. So,
hey, John?
Yeah.
Just a suggestion, if somebody's concerned about damaging their home directory by messing around the command line, create a test user and log in as a test user and have at it. And if you break it, so what? You can delete the user and re-add it.
Yeah, very good. As we say, you know, Linux is a multi-user operating system. So yeah, and one thing I've learned in a problem that I have, and thanks to the Linux guys at Brookdale, always everybody should create a backdoor user on your operating system, that if something happens to you, that you can log in, as long as the computer will boot up, log into a backup person or a backdoor. I have on my computer, I have a user called backdoor, and that one I can try and do SSHing into if my regular user isn't working right. So great, thanks so much, Orv. And as always, in the follow-up material, you'll get his slideshow so you can go back and review what he's said and try it yourself. That's all. That's the hardest thing that for me, was to just try it, get started, do a little bit at a time, and then more and more, you're using it more and more, like I hope to.
I do have a question.
Okay.
In Windows, there is System 32 folder with lots of tools. Almost no one knows about it or uses it. Is there something like this in Linux, and in which folders?
Yes, all the system utilities are in /sbin, but as root, you have a search path into that, so you don't have to be in the folder. You just run it from the command line, and it will find it and execute it.
Yeah, lots of tools, lots of tools.
Cool, thank you.
Hey, John, next
Yeah.
time remind me, I might do a quick demo on how to log in with one of the alternate virtual terminals.
Oh, yeah. While
So
you're
you
running,
can
log in.
always rescue your system that way. But you're right, SSHing in will always work.
Yeah. My problem was that I couldn't SSH into my user because it had frozen up completely. And so now I've got a back door I can get in.
Do we know what SSH stands for?
Yeah, we did a
Secure-
presentation on it, secure shell.
Thank you.